Example 7, state and explain what happens to the mercury column in the barometer in the following situations. Okay, A, more mercury is poured into the reservoir. Now, I have these two mercury barometer drawn in the diagram over here. The first one on the left is basically what you have drawn in example 6. So imagine, right, from example 6, this barometer, I'm going to pour excess mercury, okay, into the mercury reservoir such that the mercury level rises in the mercury reservoir, right? So in both barometers, what we have is this surface is exposed to the atmosphere, and this surface is also exposed to the atmosphere. So recall that the height of the mercury level measures the atmospheric pressure. So say for example, if my atmospheric pressure is a 76 cmHg, then what should this height be? This height should be equals to 76 cm, right? So given that the second mercury barometer is also exposed to the atmosphere, right, then this height over here should also be measuring 76 cm. So how does that happen? Okay, it happens because as you are increasing the level of your mercury in the mercury reservoir, the mercury reservoir also pushes up, okay, the top of the mercury column such that when you measure the height, which is from the surface to the top over here, it remains at 76 cm. Okay, why so? Because ultimately this surrounding over here is still the same atmospheric pressure. Okay, so let's go and fill in the blanks over here. More mercury is poured into the reservoir, so reservoir level rises. Mercury column will rise by the same amount, right, to maintain the same mercury height in the column. Okay, why so? Because I'm still looking at the same mercury. I'm looking at a constant gravitational field strength, and it is still measuring atmospheric pressure. Okay, B, the glass tube is tilted. Recall what you saw in our enrichment activity, right? So in station 5.1, we have this setup over here where no matter what is the shape, okay, or the diameter of the columns over here, okay, you can see that the level, the water level remains the same because all of them are exposed to atmospheric pressure, right? So as the glass tube is tilted, what happens is over here, okay, this is still atmospheric pressure, this is still atmospheric pressure, this is still atmospheric pressure. So when I measure P, which is here, P is P atmosphere, and it has to be still equals to H rho G, right? So if all the tubes over here have exactly the same liquid, which is mercury, then the height, which is measured vertically, should remain at 76 cm. Okay, so 76 cm is the approximate value. Reminder again, okay, use the values that are given in the question. Okay, so as the glass tube is tilted, the height, gentle reminder, measured vertically, of your mercury column remains the same, right, or is unchanged. Okay, why is that so? Because we are looking at rho GH, where H is measured in the vertical direction.